What are we doing today, guys? We're doing something called partial fractions. The whole idea of partial fractions is just to get an expression that has this that is equivalent to the original, and it makes it easier for us to integrate. So let's introduce you to a partial fraction. So it says write the function f of x equals x minus 13 over 2x squared minus 7x plus 3 as a sum of rational functions with linear denominators. Okay, so what that means is this. First, let's factor out the denominator. I'm going to write 2x squared minus 7x plus 3. This one's not that extreme. There's only one way to get 2x squared, 2x times x. There's only one way to get 3, 1 times 3. Now remember, I have to add it to a negative 7. So the 3 is going to go on this one, and the 1's going to go on that one. Why? Because when I multiply 2x times 3, that's your 6x. 1 times x, that's your 1x. When you add them up, that's 7x. But notice there's a negative, so they both have to be negative. See, negative times a negative is a positive, so we're good. So here's what we're doing. You see this expression? This one here is just this one that I'm writing over 2x minus 1 and x minus 3. Overall itself, at the moment, we're not integrating or anything, but what we want is an equivalent expression that breaks up that looks like this. And you're always going to have the factors in the bottom, like that. Okay, Chop, so what's the theory? Now, the proof is actually pretty complicated. If you want the real proof, you probably need grad school for that. You can look it up online, the proof of why it works or how it works. But here's what you're doing. Here's the theory behind it. So you see this a over 2x minus 1? The only way you can add up these fractions is if you have a common denominator. So I'm going to multiply this by x plus 3 over x plus 3. I'm going to multiply this one by 2x minus 1 over 2x minus 1. And here's what you have. When I do that, you know what? I'm just going to go right into it, and I'll talk to you about what's up.
Yeah, is this supposed to be x plus 3 or x minus 3?
Yeah, it's supposed to be x minus 3. Good job. Good catch. Good catch. I would have gotten it wrong. X minus 13 equals A, do not distribute, x minus 3, plus B, do not distribute, to x minus 1. And I know what you're saying, Chav. Why did you not put any of the denominators? That's for a reason. Okay, let's make sure that we understand what's happening. First and foremost, do you see how the denominator here is 2x minus 1, x minus 3? This would have been that denominator. In the bottom, I would have had 2x minus 1, x minus 3. And of course, what do? You could distribute and combine. So why am I not putting the denominator? Why? Because in a little bit, I'm going to say x equals 3, and then I'm going to zero out that factor to solve for what b is. You know what I mean? Yeah, like I need to solve for a and I need to solve for b. But if I were to put the denominator in there, well, I'm undefined at x equals 3. I'm undefined at x equals half. This is common practice. Now, do you have to use those specific x values? You don't. But it makes life easier. Especially if you have two unknowns, like to zero out one of the factors. Does that make sense? You okay, Maddie? It looks like you zoned out a little bit. But we're good, though, right?
Yeah.
Ask me.
I only zoned out for like 2 seconds.
Okay.
You got it so quick.
Okay. No, just making sure. So why do I not have the denominator? Because in a little bit, I'm going to zero out one of these factors to solve for one of the letters. And it doesn't make any sense if I have the denominators because I'm undefined at those values. This is common practice.
So is it like, are we saying the denominator like it'd be x minus 13 over that same thing, but because like if we add it, then we'll be able to factor them out because they have it on both sides. Like
I don't know if I understood.
Is that bottom part of like if you go up x minus 13 over 2x minus 1, like does that carry over to the next equation?
It would have. Like I would have had this as my denominator, and then the left side equals the right side, right? Because look what I did. I multiplied 8 times x minus 3. Notice I didn't distribute. But then my denominator would have been 2x minus 1 times x minus 3, see, for this one. Yeah. And then this one would have the denominator of x minus 3 and times 2x minus 1, which they both have the same denominator.
Oh, so you just cancel it out.
Yeah. Oh, okay. I just got rid of them so I can do what I'm gonna do next. You know what I mean? Yeah. Look, you'll see it right now.
They're basically there, but because they would just get canceled out.
Yeah. Well, okay. I don't want you to think that canceled out. They're there, but I'm not using them because I'm gonna do this. I'm gonna set x equal to 0. No, not 0. X equal to 3. Chav, why are you doing that? If I set x equals to 3, that will zero out that one right there. But see, I wouldn't be able to do that if I still have my denominator. Because I'm undefined at x equals 3. Do you know what I mean? Maddie, you know what I mean? All right, so here it is. If I set x equal to 3, 3 minus 13, that's negative 10. 10 equals, this zeroes out. See, 3 minus 3 is 0. 0 times anything is 0. And then I would have b times 3 times 2 is 6 minus 1 is 5. Do you see that? And then I can solve for b. I can go negative 10 equals 5b divided by 5, b equals negative 2. Now, what am I going to do? Let me change my colors. I'm going to zero out the b by choosing x equals a half. Do you see that? If I would have plugged in a half in here, it would have been undefined. So that's why we get rid of the denominators completely. And then I'm going to go, let's see, what am I going to go? 1 half minus 13 equals a parenthesis 1 half minus 3. And then this one zeroes out. See? So what do I have? Let's see, 13 times 2, 26. So 26 over 2. 1 minus 26 is negative 25 over 2 equals, let me replace this 3 and write it as 6 over 2. 1 minus 6 is a negative 5, so negative 5 over 2 with an a on it. You can cancel the 2's if you want, or I guess you can just multiply this by negative 2/5. Whatever you do to one side, you do to the other. Negative 2/5. Bam, bam. Negative times the negative is a positive. 25 divided by 5 is 5. So a equals 5. So what, Chav? So you got a to equal 5 and b to equal negative 2. What does that mean? That means this. That means that this expression right here, x minus 13 over 2x squared minus 7x plus 3, is equivalent to 5 over 2x minus 1 minus 2 over x minus 3. They're both the same. If you were to graph this one on the calculator and you were to graph this one on the calculator, they'd be the same curve. Does that make sense, guys? Are we okay? Are we not okay? Okay. So, Chav, why are we learning this? So, partial fractions is not a calculus topic. Well, I guess it is, but it's an algebra topic. It's a pre-cal topic. You're going to need it again in differential equations when you have higher order. You'll need it again in your other courses, Cal 2 for sure. Yeah, yeah.
Why does the B go first?
No, I made well. It would just happen because I canceled out the a. I could have made the a go first by choosing x equals a half. It doesn't matter what order. You know what I mean? So it doesn't matter the order. All right, you guys ready? No, take a seat. Take a seat. You want the notes? Oh, all right. No, it would have been fun. I guarantee you would have had fun if you wanted. Okay. All right. Let her there, Zoe. All right. Anti-differential with partial fractions. You look at it. You're going to say, can I do U sub? Can I do U sub? No. Can I do integration by parts? No. What else do you guys know?
I remember we did like, is it because it's a fraction?
It's a fraction. There's no, I mean, I guess you could, if you figure out like a fancy way, you can say 3x fourth plus 1 times 1 over x squared minus 1. And then maybe figure out like a fancy way to do integration by parts, but it's not going to work. So the other method is maybe it's partial fractions. Now, notice that the degree in the top is higher than the degree in the bottom. If it is, before you even start doing partial fractions, do long division or synthetic division. So I'm going to go 3x to the fourth plus 1. And I think you guys work better with long division here.
I'm sorry. This says I need the password again, even though just to turn the test. So I'm not sure.
Did you finish them all?
Mm-hmm.
I already forgot the password. TN6KK. Did it work? Don't worry. If you finish them all, don't worry about it. I'm sure, I'll look. Okay. All right, here we go, guys. X squared times what is 3x to the fourth? 3x squared, 3x to the fourth. And then don't forget that 1. Negative 1 times 3x squared, negative 3x squared. Put a line, put that in parentheses, put another line to subtract. These cancel out. There's nothing else that cancels out, so I'm going to write negative 3x squared plus 1. Still okay?
Is it positive?
Oh, yeah. You're right. It is positive 3x squared. Minus a negative is positive. Man, errors galore. Okay. We're still okay? All right. I was testing you. All right. Next. X squared times what is 3x squared? 3. So put a 3, put a 3x squared. And then 1 times 3 is a negative 3. Subtract that. So that zeroes out. And then that's going to be a 4. That's my remainder. So I'm going to write plus 4 over x squared minus 1. So this integral turns to integral 3x squared plus 3 plus 4 over x squared minus 1 with a dx on it like that. So now, look at this. That's easy to anti-differentiate or to take an antiderivative. That's easy to take an antiderivative because that's just a polynomial. But this guy, you can't do u sub. You can't do integration by parts. So it must be partial fractions. I'm going to come to the side. I'm going to change colors. And I'm going to go, that is 4 over, I guess I'll write it as 4 over x plus 1, x minus 1. So what do? I put an equal sign. This is a linear. So I'm going to write a over x plus 1 plus b over x minus 1. And I know if you're a graduate student and someone's looking at my YouTube channel right now, you're probably saying, well, that's a quadratic x squared minus 1. You could have just done ax plus b. But we're working with rookies here. This is our first time that doing it, so we're doing it this way. There is another way, but we're not at that level. Are we still okay? All right, so here we go. I'm going to go ahead. I need to get a common denominator. So I'm going to multiply this one by x minus 1 over x minus 1. This one by x plus 1 over x plus 1. And here's what I'm going to have. I'm going to go back to blue. I'm going to have 4 equals a parenthesis x minus 1 plus b parenthesis x plus 1. We're still okay? All right. I'm going to choose. What am I going to choose? I'm going to choose x equals 1. When I choose x equals 1, the a goes away. You know what? I'm going to choose negative 1. I'm just going to put a negative in there. See, like that. Because Montanes told me last time, how did you do b first? Look, now I'm doing a. Doesn't matter which one you do first. So I'm going to write.
Wouldn't you be doing b if you made it a negative 1?
If I make a negative 1, the b cancels out. Because it zeroes out.
Oh, yeah, okay.
4 equals negative 1 minus 1 is negative 2. So I'm going to have negative 2a. And then this will be 0. So that means a equals negative 2. We're still okay? All right, now I'm going to set x equal to 1. Now the a is going to cancel out. So I'm going to have 4 equals 2b. Divide both sides by 2. b equals 2. Now, guys, you don't have to do it this way. Once you have 1, anything would have worked. So don't write this down, just listen. So if I would have said, once I have this, if I would have said, well, I want x equal to 0, you could have done that. 4 equals, and look, I already got a is negative 2. Negative 2 times negative 1 plus 0 plus 1 is b, right? Or b times 1. And look, you would have gotten the same answer. 4 equals 2 plus b minus 2 minus 2. B equals 2. OMG, we would have gotten the same. So if I said that if you don't want to zero them out, zero out the factors. I just said x equals 0. See, I got color coded. X equals 0. I already know what my is. Negative 2. I didn't zero it out. You can do that, but only once you have like one of the letters. You know what I mean? So usually the common theme is you want to zero out your factors so you can isolate your letters. Okay. All right, here we go. So now I'm going to go back to red. So now I have this. I have integral of 3x squared plus 3. And then let's see, what was a? Negative 2. No, let me do the b first because the b is positive. So plus, and then the b was over x minus 1. So 2 over x minus 1 minus, the a was negative, 2 over x plus 1. It was a dx. All right, let's see what that is. I'm going to put the arrow over here. I'm going to write the answer here. X. What's antiderivative of 3x squared? X cubed. So I'm going to put the equal sign. Plus antiderivative of 3. 3x. Antiderivative of 2 over x minus 1. 2 ln absolute value x minus 1 because there are no there's no limits on my integrand symbol on my there. So minus, what's the antiderivative of 2 over x plus 1? X plus 1 plus c. You could leave it like that. That is the answer. But you see how I have a 2 ln x minus 1 and a 2 ln x plus 1? I'm going to factor out a 2, and then I'm going to use the quotient property. So here's my final answer. I'm going to write equals x cubed plus 3x plus 2 ln absolute value x minus 1 over x plus 1, close it, plus c. There it is. What do you guys think? We're pretty good? Okay, let's go to the next one. It says find 3 partial fractions. So we're just doing, it's not calculus, we're just doing partial fractions. That's all we're doing, guys. So here we go. I am going to expand this. 6x squared minus 8x minus 4 over x plus 2, x minus 2, x minus 1. I'm going to equal this to a over x plus 2 plus b over x minus 2 plus c over x minus 1.
Will the process be the exact same?
The process is the exact same. When I multiply my common denominators, I'm multiplying this a1 by x minus 2 times x minus 1. Do you guys see that? So here's what I'm going to have. 6x squared minus 8x minus 4 equals a parenthesis x minus 2 open close x minus 1 plus b parenthesis x plus 2 close open x minus 1 close open plus c parenthesis x plus 2 close open x minus 2. Maybe you write that one as x squared minus 4, but I like it like this. Are we still okay? Which one do you want to solve for first? A, B, or C? It does not matter to me. A? Okay. If I want to solve for A first, I need to set B and C. I need to set X equal to negative 2. So I'm going to color code these. I'm going to put this blue. X equals negative 2. If I do that, the B will zero out because I have an X plus 2 term, and the C will zero out because I have an X plus 2 term. Do you guys see that? So here's what I have. Negative 2 squared is 4. 4 times 6 is 24, so 24. Negative times the negative is a positive, so plus 16 minus 4 equals, I'm just plugging in negative 2. To everything. No, to x.
To the left side of it.
Yeah, that's the left side.
Oh, we're doing to the left side.
Well, I'm just plugging it into everything. Equals a parenthesis negative 2 minus 2, that's negative 4. Negative 2 minus 1, that's negative 3. And then that will zero out this one and zero out that one. Are we still okay? 24 plus 16, 24, 34, 44, 40 minus 4, 36. 36 equals 12a. Divide both sides by 12. A equals 3. There's my A. Are we still okay, guys? I'm going to choose a different color. I'm going to choose green. And which one do you guys want next, the B or the C? Should we just go in order, A, B, C? If I want the B, that means I have to type in 2 for x. X equals 2. So here's what I have. 6 times 2 squared. 2 squared is 4. 4 times 6 is 24. So I'm going to have 24 again. Minus 8 times 2 is 16. So this time it's going to be a minus. Minus 4. Equals, and then let's see. I already know the A. That's going to zero out the B. So B times 2 plus 2, which is 4. And then 2 minus 1 is 1. And then the C zeroes out. Difference between 24 and 16 is 8. Minus 4 is 4. So I have 4 equals 4B. And from that, I get that B equals 1. Are we still okay, guys? Okay, I'm going to choose purple, one of my favorite colors. And if I want to zero out A and B, you choose what X value? 1. See? So 6 times 1 squared minus 8 times 1 minus 4 equals, let's see, A and B zero out. C parenthesis 1 plus 2 is 3, and 1 minus 2 is negative 1. So let's see what we get. 6 minus 8 is negative 2. Negative 2 minus 4 is negative 6. Negative 6 equals negative 3c. C equals 2. All right, here's my answer, guys. This fraction, let me write it right here. This fraction, 6x squared minus 8x minus 4 over x squared minus 4x minus 1 is equivalent to 3 over x plus 2 plus 1 over x minus 2 plus 2 over x minus 1. We got 2 free response questions, so 30 minutes. Is that okay? Okay. All right. All right, guys, there it is. Now let's just apply it. So this is from the 2009 AP exam, and let's see what it says first. Consider the family of functions f of x equals, this is from the BC exam. F of x equals 1 over x squared minus 2x plus k, where k is a constant. Find the value of k for k greater than 0, such that the slope of the line tangent to the graph of f at x equals 0 equals 6. What do I need if I want a tangent line? What do I need, Montanes? Point and slope. Do I have a point? Kind of, yeah. When x is 0. So if I plug in 0 in there, I should be able to get my point, right? Let's see. Well, they want me to find the... Yeah, so let's... Find the value of k for k such that the slope of the line tangent... Oh, they want the slope to be 6. Okay, so here we go. We're going to take the derivative. Find the value of k. Never mind. They don't want a tangent line. They just want the value of k. So, ready? Take a derivative. So here we go. F of x, I'm just rewriting it. Parenthesis x squared minus 2x plus k to the negative 1. Sorry. I'm just finding where the k, where my slope is... Find such as the slope of the line tangent to the graph of f at x equals 0 equals 6. They want the k value that makes the slope equal 6. Derivative equal to 6, solve for k. Plug in 0. All right, here we go. F prime of x. Chain rule, negative 1 in the front. X squared minus 2x plus k to what power? Negative 2. And then times, we're not done yet, times what? 2x minus 2. Let's rewrite it. So f prime of x, that's f, equals, let's see, negative in the front there, 2x minus 2 over x squared minus 2x plus k, close it, square it. All right, you guys ready? I'm going to start a new line because they gave me a x equals 0, and I'm going to say this. I'm going to go f prime of 0 equals negative, that negative is that negative, and then I'm going to put some space. Don't let that negative get next to the 2x, so then you're going to think that 2x is negative. 2 times 0 minus 2 over, I'm plugging in a 0, guys. 0 squared minus 2 times 0 plus k. I guess you don't have to show that if you can see it. And I want this to equal what? 6. Cool or not cool? Here's what you have now. You have negative in the front, negative 2 in the numerator, and in the bottom you have k squared equals 6. It turns to algebra now. Negative times a negative is a... So maybe you can skip some of these steps if you're like really in tune with your algebra. I'm going to multiply both sides by k squared. So 2 equals 6k squared. And then divide both sides by 6. So k squared equals 1/3. And then how to get rid of the square? So you can have your answer in all these different ways. You can leave it as the square root of 1/3. You can leave it as law of exponents goes into place. Square root of 1 over square root of 3. What's the square root of 1? So 1 over square root of 3. Or you can leave it as square root of 3 over 3. Which one do you like best? First one? Okay, leave it as the first one. I kind of like this one the best. The second one. But the first one's good. Leave it as the square root of 1/3. Cool or not cool? Okay. Let's go to the next one. Are you guys doing okay? Okay. For k equals negative 8, find the value between 0 and 1 of f of x dx. Okay, so here it is. I'm going to choose blue. I'm going to first write that equation there, guys. F of x equals 1 over x squared minus 2x minus 8, because k is negative 8. And before we integrate, so that's what I'm going to integrate. Before I integrate, I want to see what that is. I'm going to factor it out. X squared minus 2x minus 8. So two numbers that multiply to give you negative 8 that adds up to a negative 2. Yep. And I make sure that I'm defined everywhere between 0 and 1, and you are. You're defined everywhere. You're just not defined at negative 2 and at 4. So you're fine. So here we go. I'm going to do partial fractions. So I have 1 over x minus 4, x plus 2. Why am I doing partial fractions? Because you can't do u substitution and you can't do integration by parts. So a over x minus 4 plus b over x plus 2. Here we go. I'm going to go to red here. 1 equals a parenthesis x plus 2. Because remember, we multiplied a over x minus 4 by x plus 2 over x plus 2. Plus b times x minus 4. Are we still okay? All right. You guys want to go in alphabetical order. So I'm going to set x equal to 4 to 0 out the b. And you get 1 equals 4 plus 2 is 6. 1 equals 6a. So a equals 1, 6. Are we still okay? Am I going too fast? Should I slow down? Okay. Let's go to the, I'm going to push green. I'm going to set x equal to negative 2. If I do that, the a zeroes out. And we could, if you didn't want to zero it out, that's fine. You could have chosen x equals 0 or something and plug in a equals 1, 6. But that's going to complicate things, in my opinion. 1 equals the negative 2 plus 2 zeros out with the a. So I'm just going to, I'm going to go ahead and just plug in the negative 2 over here. Negative 2 minus 4 is negative 6, so negative 6b. So there's my b. And what I meant by complicate things, I meant that it might just make things a little more arithmetic tougher, maybe. Or maybe not, but there it is. Your a and b is 1, 6 and negative 1, 6 respectively. So now, here's what I can do. This integral right here is the same thing as saying integral from 0 to 1 of, let's see, which one am I going to put first? The a. Of 1, 6 over x minus 4. You can put the 1, 6 out if you want. Minus, you can factor out a 1, 6 actually, because both of them are 1, 6. 1, 6 over x plus 2 dx.
You can just flip it, right? Like put the x minus 4 above the 6 and the x plus 2 above the other 6.
Oh yeah, like put it like 1 over 6 parenthesis x plus 4?
Well, I was thinking x minus 4 over 6.
No.
Oh,
Keep change flip. This is x minus 4 over 1. So it goes right next to the 6 if you were to do that. You know what I mean? So, or AB over C, so you can just put right next to the 6. I wouldn't. I would just leave it. Antiderivative, here it is. 1, 6 ln x minus 4, close, minus ln 1, 6, 1, 6. Put a 1, 6 in the front. ln x plus 2, close. Big line, 0 to 1. I am going to, you see how they both have a 1, 6? Factor out. You're done with calculus. Now you're just doing algebra. 1, 6, 1 ln, giant parenthesis, x minus 4, or giant absolute value over x plus 2. Close it. Evaluation line, 0 to 1. Upper minus lower. I'm going to factor out the 1, 6. Big bracket. If I plug in a 1, 1 minus 4 is negative 3. 1 plus 2 is 3, negative 3. So I have ln of 1, because the absolute value, minus, and then if I plug in a 0, negative 4 divided by 2 is negative 2, but absolute value of negative 2 is 2. So my final answer, what's ln of 1? 0. My final answer is 1, 6, negative 1, 6, ln of 2. Because of this negative right there, it's negative ln of 2. It's up. I did upper minus lower, right?
Oh, okay, yeah. It's because the ln,
Yeah, upper minus lower. And there it is. How do we feel? Now, I already did this earlier with, what happened? It's absolute value. It's absolute value. Right there. Right? Okay. All right, here we go. This we have not done yet, guys. I told Moreno we did it because Moreno wanted to see it. Well, actually, I didn't even question if she wanted to see it or not. We just did it, and then this is called an. Well, let's just go for it and see what happens. See how they tell us that k equals 1. So if I write x squared minus 2x plus 1, this can be factored out into x minus 1 times x minus 1, right? Which is the same thing as x minus 1 squared. So what I have here, here's what I have. I have integral from 0 to 2 of 1 over parenthesis x minus 1 close it squared dx. What's wrong with this picture?
It's not continuous all the way.
Yeah, it's not continuous all the way because look, this means you're going to the curve from 0 to 2, and it's not continuous at x equals 1. So there's a name for this. It's called an improper integral. This is not the only type of improper integrals. There's other types, but this is called improper. We're going to do a full-blown lesson. Don't worry, it's not even that bad. There's an improper integral, and you're going to see it's not that bad. Whenever you have an improper integral, you see where it's not defined? I'm going to write x equals 1 is where f of x is undefined.
Do you like split it up into two different?
We are. And we're going to give it a letter so we can integrate this. So here's what we're going to do. So we're going to split it up. We're going to go limit. And I like to go down the alphabet. I'm sure if you look at a textbook, they like to use the letter B. Angie Alvarez, what letter do you guys use at U Chicago? Do you guys use the letter B also? It doesn't matter what letter you use. No, I'm going to send her the video. So yeah, I just like to go down the alphabet, guys. So I'm going to use the letter A. So I'm going to say as A approaches 1 from the left, because we can't approach 1 from the right at the moment, we're going to do two integrals. And you go integral 0 to A of this function, 1 over parenthesis x minus 1 close it squared dx, plus limit as A approaches 1 from the right from integral from A to 2. Yeah, because we have to go 0 to 2, right? So there it is. There's my splitting up. 1 over x minus 1 close it squared dx. Does that make sense to you?
So why do we do limit? Why not just split them up into two different integrals?
Because we can never be x equals 1. We can't say from 0 to 1 because you'll never reach 1.
So integrals is like including that point.
Yeah, well, these are definite integrals, right? So this, if I have a definite integral, this right here is saying area under the curve from 0 to 2, but at x equals 1, you're not continuous. You can't.
It's defined at 0 and it's for sure defined at 2.
It's for sure defined at 0, it's defined at 2. It's not defined at 1.
So the limit is just saying as close as we possibly
Yeah,
can.
we're getting as close as we can to 1. So notice now my integral symbol is fine. You cannot write 0 to 1. You cannot write that. You write that, it's going to be wrong. Boom. Automatically. Don't do that. There's a big deal on this test. Cool. All right. Continue with the limit. We haven't evaluated it yet. Limit. As A approaches 1 from the left, bracket, I'm going to do my antiderivative. What is the antiderivative of 1 over x minus 1 squared? There's that day that I had a mini tantrum. Not a big tantrum. You can if you want. Okay, here's the way to do it quickly. X minus 1 is a linear pair, so it's like saying 1 over x squared.
It's just a negative 1 over x.
Yeah, negative 1 over x minus 1. Hopefully we can do that fast. Are we okay, Maddie? The baddie? Okay, we're fine. All right, don't be mad, miss. Evaluate it from 0 to A. I guess you could also put that inside, but actually, you know what? You can use those brackets. It doesn't matter. The right way is to do that line, by the way. Okay, there's my line. Plus limit as A approaches 1 from the right of negative 1 over x minus 1 from A to 2. Are we still okay, guys? All right, here we go. Limit as A approaches 1 from the left. And then in here, I'm just going to do upper minus lower. Negative 1 over A minus 1 minus a negative. Can I put a plus? Is that okay with you guys? Tell me no if you don't think it's okay. plus limit. Okay, I'm going to slow down. Does that make sense so far?
Wait, would it be -1 over -1? Oh, wait, no, you said it's positive.
Yeah, minus a negative.
Oh, yeah.
Limit as a approaches 1 from the right. -1 over, I'm just plugging in the numbers. I'm just plugging in the upper minus lower. Minus a negative, so it's going to be plus 1 over a minus 1. Are we still okay? All right. There is a discussion to be had about different infinities. You know what? I'm giving the answer away.
Would that be like -1 -1?
This is -1 right here.
Okay. It's plus because we're subtracting it.
And
Okay. Yeah, I was confused about that for a second too.
oh yeah, it's plus because it's minus a negative. I'm pretty sure I said that. Okay. Okay. Are we still okay?
Is that how you're supposed to do it? Like you can't like say since the 0 minus 1 is just -1 and then that's just -1, you can't like write -1?
Or you can.
I think you're just a step ahead.
Yeah.
Oh, okay.
Yeah, you're just too good. I'm just trying to show all the little details.
Okay.
All right. As A approaches 1 from the left, so think about this number. Think about what that could be. So if I approach from the left, I'm talking like 0.9, 0.99, 0.99999. So think about it. So it's going to be, negative. And I have a 1 in the top. 1 divided by a negative, really, really small number is going to explode. Like it's going to be a very big number. It's going to be approaching infinity. Yeah. That's going to be approaching infinity. This guy. Negative divided by negative is a positive. When I mean negative, that guy, right? So look, this is going to be, the denominator is going to be approaching a very, very small negative number. Negative 0.1, negative 0.01, negative 0.001. Child, what are you talking about? 0.9 minus 1 is 0.1, right? 0.9 minus 1, 0.1. Or negative 0.1. You know what I mean or no? Okay, don't scare me, guys. So this right here is approaching positive infinity. As soon as you see an infinity, diverges. This all collapses. So you're going to go integral 0 to 2 of f of x dx diverges since limit as a approaches 1 from the left-hand side of 1 over x minus 1, or actually a now that I'm a minus 1 equals, and I guess I should put negative there, equals infinity.
Aren't you not supposed to say it equals infinity? Or
You can, yeah, you're right. You're not supposed to say is equals infinity. Is infinity. You must be reading the forums.
No, I don't know. I just have a core memory being like nothing technically equals infinity.
Yeah, you can never equal infinity. You're right. A teacher told me that too when I was presenting to them. I'm like, yeah, it's a formality though. I mean, we write equals. So there it is. Now I kind of, guys, by the way, I'm warmed up. So I knew that this was the answer because I did it with Moreno a little while ago. But here's something for a discussion. I see this as infinity. I see this guy right here as negative infinity. And I know we're not supposed to add or subtract these infinities because not all infinities are the same. But the rate, like the rate of growth, the rate that this graph is increasing is the same rate that this one is decreasing. So I kind of see them as those canceling out. That's what I saw initially. But the rubric said, nope, as soon as one is approaching infinity, the whole thing collapses and it diverges. So, yeah, that's it. We're done. As soon as you see one that is infinity, like, does that make sense, guys? Okay. I'll show you the rubric. Is that it? Are we done? What year was that?
Are we going to ask about like diverging infinities on PC?
Yes. I hope there are going to be a whole bunch. Look, there's one. It's mainly for series, though. Mainly for series. We haven't talked about series yet, guys, so we need to get there quickly because we don't have much time left. 2019? All right, free response, PC, scoring guidelines. 2019, you said, right? All right, here it is. 2019, question 5. Did we get the answer for letter A to be 1 over square root of 3? All right, there it is. You could have left it as square root of 1/3. It's fine. For letter B, did we get A and B to be 1/6 and negative 1/6? Yes, we did. And did we get this as our final answer, negative 1/6 ln 2? Yep, we got all 3 points, guys. Letter C. Look how they said it. We got all the points. We did it exactly the way they did it, except they used the letter B. And I kind of like, that they put that on the inside instead of the outside, but that's fine. I think we're good. Let's see. Because limit as x approaches 1 from the left of negative 1 over b minus 1 does not exist, the integral diverges. Done. Infinity is the same thing as saying the limit. You do not exist. You know what I mean? How do we feel?
Do we put like infinity or does not exist?
I think choose one or the other. They're both the same. You can never reach infinity, so the limit does not exist. All right, one more, guys, and then we'll call it a day. You guys ready for this one? Hey, don't talk smack. I don't know what you guys are talking
She's talking about.
about. Oh, okay. Sorry, miss. All right.
No, I'm not at all.
Consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. The derivative of f is given by, and then give you the derivative. They're being nice. They don't have to give you that. This is a BC question, guys. It is 100% BC. Let k equals 3 so that f of x equals 1 over x squared minus 3x. Write an equation for the line tangent to the graph of f at the point whose x coordinate is 4. That's all AB. There is no BC in that. Now, what do I need for a tangent line, Montanes?
A point and a slope.
That's right. Did they give us a point? Kind of. They gave us x equals 4. So we can get a point by plugging it into the original. F of 4 equals 1 over x squared, 1 over 4 squared, minus, a total of k is 3 times 4. So 1 over 16 minus 12. So 16 minus 12 is 4. So my coordinate is 4 comma 1/4. We still okay? All right, here we go. F prime of 4 equals, they told me that k was 3, so 3 minus 2 times 4 over parenthesis 4 squared minus 3 times 4 close squared. Let's see what that is. 2 times 4 is 8. 3 minus 8 is negative 5. And on the bottom, 16 minus 12 is again 4, and 4 squared is 16. There's my slope. All right, tangent line. Tell me my tangent line, Montanes.
Y minus 1/4 equals negative 5 over 16 parentheses x minus 4.
Yes. You got the full credit. What's going on, Maddie?
I don't remember. Yeah, that when we're finding the slope. Yeah.
There's two different ones. So this equation specifically says that like this is f of x, and then the one up there says f prime of x.
Yeah, I'm like,
Oh, we do
I
have
don't remember how we got like the 3 minus 2
that's
like on the top.
Right there.
from f prime because when you look at the derivative.
They told me what k is.
Yeah, I honestly took me a minute.
Okay,
so I'm
so
like, where do you
if
get that
they
equation
didn't give
from?
I was like,
us-
dang, he did that really quick.
If they didn't give us f prime,
We'd have to do it by hand.
you would do by hand. So the derivative of like f is the slope.
Yeah, the derivative has the slope. If I had to take a guess, I think they gave you the derivative to be fast. Because,
I thought you just solved it really fast. I was like,
well, you could have. Yeah, no, you could have solved it, but I think that's why they gave us that derivative. I don't know, because I wasn't part of the committee that created the test, but
Because if you did chain rule,
Yeah, yeah.
then that's why it shows up at the top. Oh, wait, that's why it would show up at the top, because negative kx would just be negative k, and then you did x squared is 2x.
they gave you everything. They gave you the derivative and they gave you k. You know what I mean?
So you can solve it yourself.
All right. Can we go to the next letter, guys, or no?
Yes.
Let k equals 4. Look, they're giving us k again. So that f of x, so now they look, this is my f of x right there. Determine whether f has a relative minimum, relative maximum, or neither at x equals 2. I love it. You have a max whenever what? You guys tell me.
Goes from positive to negative.
What goes from positive to negative? Don't say it.
The derivative.
The derivative of f. So say f prime. Don't say the word derivative because then it's like, what derivative? I know we can probably use context clues and assume that you're probably talking about this one, but you don't want to give them any reason for them to, do 100% do not use the word it. They always emphasize it. It says it. It is positive or it changes from positive to negative. What is it? Okay. There you go. So first, let's see if f prime of 2 is 0. So I'm going to first write my derivative. F prime of x equals, they told me that k is 4. Let me zoom out so I can see it. So look, I'm not doing it. I'm not taking the derivatives really, really fast, Miss Aguilar. I'm just getting it from here. So 4 minus 2x over x squared minus 4x close it squared. So I didn't do it. I just wrote it from up there. I just wrote the k. Cool or not cool? Right. F prime of 2. 4 minus 2 times 2 over parenthesis 2 squared minus 4 times 2 close squared. As long as the denominator is not 0, and it's not, I get 0 over, 4 times 2, 8, 4 minus 8, 16, which is just 0. Matter of fact, if you want to be safe, don't even write 0 over 16. Just write equals 0 right off the bat as soon as you see it. So it equals 0. Are we still okay? All right. I'm going to do a number line. And a number line is not enough. You got to say it with words. I'm going to put a 2. And I'm going to check to see if my symbols change from positive to negative or negative to positive. I don't care about the denominator. Here's my derivative equation, guys. Why do I not care about the denominator? Because it's always going to be positive because it's squared. Good job, Montanes. Yeah, maybe you should bring your mom more often. She's doing amazing today. All right, sorry. I'm not trying to throw you under the bus. I'm sorry, miss. All right. Okay, that's all. It's all jokes. It's all jokes. Yeah, please. All right, here we go. When x is 0, what's 4 minus 0? Positive or negative? Positive. When x is 3, 2 times 3 is 6. What's 4 minus 6? Negative. So it changed from positive to negative. So at x equals 2, f has a what? Max. So there it is. I'm going to say that. Say it with words. This is not enough. You need to say it. So I'm going to say f has a max at x equals 2 since f prime changes from positive to negative at x equals 2. And I know it sounds funny to be redundant, but be redundant. Does it work? Did it work, the charger or the power? Did it work? Because sometimes it's not turned on. Yeah. Okay, how are we doing, guys? Okay, don't worry. We're almost done. Let's go to the next one. I was a little shocked initially when I did this question with Moreno, because initially I was kind of like, are they asking what I think they're asking? Because it was too easy almost. So let's read it. Let's see what. And I guess I shouldn't say that because easy is relative, right? So it says, consider the function f of x equals, so it's the same thing. Letter C. Find the value of k for which f has a critical point at x equals negative 5. You have a critical point whenever your derivative is what or what? 0 or undefined. I already have my derivative right here. They want me to find the value of k where I have a critical point, and look, they give me the x value. So all I got to do is make this equation equal to 0. So I'm going to write, this might be a point, f prime of x equals 0. So then I'm going to go k minus 2 times negative 5 better equal 0. How come I didn't put the denominator down there? Yeah, it's squared. It's always positive. I don't care about it. I guess you can make a case for factoring out the x, but it's not going to help you. X minus k there. All right, so here it is. Ready? So k and then negative 2 times negative 5 is minus 10. I guess if you want to show that minus 10 equals 0, k has to equal 10. Done. That's it. That was fast. Yeah. If I want to have a critical point at x equals negative 5, I probably should put f prime of negative 5 in here like that. Yeah, put the negative 5 in there instead of x because you want the derivative to equal 0 at negative 5 because that's where you have a critical point. You know what I mean? Come in.
Wait, wouldn't it be negative 10 because negative 2 times negative 5 is
Positive 10. Yes, you should have told me, miss.
Oh, I just noticed right now.
I got it right in the earlier, but I got it wrong right now. But I was testing. I was testing you
I
guys.
thought you were putting the negative separate from the 2 and negative 5, so I was like, okay, maybe that's.
No, there it is. That's it. All right, here we go. Last one, and this one was this was the question that this is the reason why we did what we did. Let k equals 6. What we did the lesson today, right? So that f of x equals 1 over x squared minus 6x. Find the partial fraction decomposition for the function of f, and then find the integral of f of x dx. It has no limits. All right, so first let's do what they tell us to do. 1 over, I'm going to factor out an x, and I'm going to write x minus 6. So what did I do? My factors, I'm going to write a over x plus b over x minus 6.
Why did they tell us that k equals 6?
So we can do partial fractions on this one.
Well, why would we do that if there's no k involved in the original?
It's part of the problem, miss. They don't think, there's no rhyme or reason. They just want us to,
They already have it plugged
yeah.
Okay, I was like, where do we plug that into? There's no k.
Yeah, that
Just
6 is
use
right
page
there.
6.
And then you
I
Yeah.
guess to make it consistent because they said f of x is this.
Yeah.
Okay.
Ready? 1 equals a parenthesis x minus 6 close plus bx. Are we still okay? I'm going to set, let's see, you guys want to solve for a first, so I'm going to set x equal to 0. 1 equals negative 6a. So a has to equal negative 1, 6. Are we still okay? All right, now let's get the b. I'm going to set x equal to 6. And I'm going to go 1 equals 6b. So now b equals 1, 6. Those 1, 6s have been coming out a lot lately. All right, next. Integral. And I always like to have the positive ones first, so I'm going to write the b one first. I'm going to write 1, 6 over x minus 6. And then I'm going to write minus 1, 6 over x dx. You can make a case to factor out the 1, 6 and put it in the front if you want. If you want to have like 1 over x minus 6 minus 1 over x, I think you can make a case for that. Do you want me to factor out the 1, 6 or do you want me to leave it alone? Leave it alone? Okay, all right. Here we go. 1, 6. Let me write it bigger. 1, 6 ln, absolute value of x minus 6, close it, minus 1, 6 ln, absolute value of x, close it, plus c. Your properties of logarithms, you're going to use the quotient property. Both of my natural logs have 1, 6 in the front. So I'm going to go 1, 6 ln, absolute value. And you got to put an absolute value, guys, because I don't have any limits. X minus 6 over x. I would leave it right there alone. Don't try to do anything fancy with that. Plus c. Shall we look at the rubric? What year was this? 2015. 2015. All right, here's the rubric. Did we get, look how they distributed the points, guys. 2 points, one for the slope, one for the tangent line. Did we get the slope of negative 5 over 16? Is our tangent line, we said y minus 1/4 equals negative 5 over 16, x minus 4. That's how we wrote it. That's how I think you should write it. Unless, if you feel confident, you can move the 1/4. This is about as much work as I think you should do. We got the full points there. Letter B. We set the derivative equal to 0. Well, we checked that it would equal 0 first, so we got the point there. It says considers f prime a 2.
So you have to equal to 0 before finding critical
Well,
point.
because the critical point is 0 or undefined, right?
Yeah, so you can't just trust it.
Yeah, you can't just trust it. You gotta make sure. So there it is. F prime of 2 equals 0. And then look, let's see how close we wrote to there. F prime changes sign from positive to negative x equals 2. Did we say that? Therefore, f has a relative max at x equals 2. All right, we got it. And then look at letter C. They said f prime of negative 5. Initially, I think I wrote f prime of x, but I did change it. F prime of negative 5, does it equal 0? Yes, it does. Well, that's what they want. They want a critical number. K is negative 10. There's the answer. It was worth 1 point. I wonder why I just won. Letter D was worth 4 points. Partial fractions, A equals negative 1/6, B equals 1/6. We got that because I remember saying let's put the B first in the integral. They put the negative 1/6 first. I kind of like putting the positive ones first. And there it is. They got the same antiderivative that we got. How do we feel? Okay, did we do a good job with going over this pretty good? All right, I put some practice on Delta. Log into AP Classroom. There's some videos for you guys to watch. None of it is mandatory, guys, but I would really like for you guys to do it because, we have a BC exam.